Okay, so we're going to be doing question 110, balancing a binary tree. So for this question in particular, the main getaway is that we need um, to measure the height for your left and your right, and you want to make sure that the longest height, or when subtracting both of them together, right, that it's not greater than 1. So to kind of have a visual example of that, for example, one over here, this is our binary tree, right? And we need to check your left side and your right side, right? And this is our root. This is where we're starting. So let's take a look at the left, right? The left side is only 1, right? So we've only moved down once. So your value for left is 1. And then now we're going to look at the right side starting from our root here, right? So now you're going to check on the right. And you could see that you have, starting at 20, you have a left and you have a right. But overall, your side is going to be 2, right? So you have 1 and 2, 1 for your left and 2 for your right. So what you want to do is subtract them. So subtract left by right, 1 minus 2. And let's say just taking away, let this be a negative number, like overall your difference, that's the key word, your difference is 1, right? Okay, so now we want to basically make like a condition statement saying if left minus right is greater than 1, we want to return false, right? The reason why we return false if it's greater than 1 means that it's unbalanced because the difference is larger than 1. So that's the math term that you have to remember in this problem, is that when checking these trees, we want to make sure that the difference between the left and the right is no larger than 1. If it is, then it's unbalanced. If it isn't, then it is balanced. So now we have an idea like, okay, like we know the if condition that we need to make. This is definitely going to be in some form of code, right? We know that we need to find the height of our left, we need to find the height of our right, and then we need to subtract it and then meet this condition. And if this condition isn't met, then overall just return true, right? So how are we going to make this into code? So what's going to happen is the first thing we're going to do is make everything set equal to true, um, and just make a variable to hold that, right? So what we could do is make a variable and we'll call it balanced. And because we're using recursion, instead of just setting this equal to true like this, we're actually going to make it into a list, and within the list just set it true. And the reason for that is because we're going to make a helper function. So we'll just make a helper function here. And because we're using recursion, right? And recursion is just a fancy way of, it's kind of, think of it like a while loop, right? Like something's going to continuously happen forever. But instead of just using that while loop within the same function, we're going to create a whole other function and not even use the while loop. We're going to be recalling this function over and over and over until a condition is met. So I'm going to show you how that looks like in a second. But we need an argument in order to do that. And we're working with the root, right? So our root will be our the argument we pass in. But for now, let's just name it node to keep things a little bit more simplistic. Um, and the main reason, like I was saying, that we need this as a list instead of just normal is because you cannot edit a variable value when it's inside another function. So let's say if I was to make like balanced equal to false, this wouldn't work, right? Because it needs to be in a list. So you could do balance at index 0 equals false, because now instead of editing uh, the actual variable's value, like um, you're affecting the list, right? And this is kind of like a like a uh, like a shortcut, right, in order to get away with this. Um, but overall, that's why we need to do this. So keep in mind when you're working with functions within functions, specifically with recursion, that you're going to need to when creating variables that you want to have access to outside, they need to be in some sort of list like this, right? So you can edit them. Um, so now that you have that, now we have to do the active recursion, right? So this is when we need to make certain things like edge cases and return statements and so on. So the first thing we're going to do is make an edge case. Um, so what this is basically sort of like if statements to stop the code whenever something happens. And this is probably one of the first things you should be thinking of when doing recursion problems. Um, this edge case in particular is universal because you're going to have to do this when working with binary trees. So think about it, right? If we're going down left and right over and over again, then one thing we need to check is once we hit the last node, right? We need to know when to stop. So, if our node is none, right? If there is nothing here, here, or in this example, here, here, or here, here, right? We don't want to continue going because then it would be a loop forever. We want to stop. So what we could do is just do if not node, return 0, right? And this if not node situation is basically saying, okay, so if there is not a node where we're at right now, if the value we're in right now is nothing, just return 0, right? So that's our edge case. And then we need to then set variables. And these variables is where the recursion is going to happen. So like I mentioned, recursion is kind of like when you call the function within a function. So if you're calling the same function you're in right now, then that should give you a hint that we're going to call helper, right? But then what are we going to put inside as an argument? Well, what you're going to do is if this variable is equal to left and this is equal to right, then you should sort of have an idea that, okay, so if we need to move left for one of them and move right for the other one, right? Then maybe we could do node.left and node.right, right? So left and right are now equal to basically these sections of your binary tree. So to help better visualize that, right? Because I was a little bit confused when doing this. This is your root, and you have your left section and you have your right section, right? Your left section in this instance represents all of this area, right? And not only does it represent all this area, it also represents kind of like the nodes that branch off, right? Obviously in this example there's none, but they do represent that. And the same thing goes for your right section, right? So, starting at right, which would be your 20, you would check left and you would check right. And these little areas are connected to your right. So basically this whole section right here, right? So now as you have your left and right, we need to return. When doing recursion, you always have to return. So your function knows, okay, like this is what we're continuously doing, right? So we're going to return the max of left and right plus 1. Now, there is something that we're going to write here, but this return statement is really important because I think it kind of gives you an example of what you need to be looking at. So to follow, let's say we're starting with left, right? Left is the first thing. So what happens when this variable runs? So left equals helper, this function here, node.left. So this basically just runs this function, right? Okay, so this node is going to start here at left, right? So this is where we're starting. And we want to just continue. How do I emphasize this? We want to continue running the left area, right? So imagine instead of starting at our root, we're starting here. Okay, so we want to check our left, right? Check our left is 0. And then you want to check our right, which is 0, right? So for this return, your left is equal to 0 because there's nothing here. And because your left equals 0, you return 0. And then you go to your right. Okay, what's our right value? It's 0, right? So 0, return the max of 0, 0 is 0. And then you add 1. So now this is how your left area is equal to 1, right? So left equals 1. Now that may be confusing. I think the right example is a little bit better. But let's say looking at the right. So we want to run this line right here, which says helper, our function, and as the argument node.write. Okay, cool. So we're going to return, right? We're going to return, run this line, line 26, and as our argument, we, instead of node, we're at node.write, which is 20, right? So this is where we're starting. And we are first going to look at our left, right? So it's like a left at 20. You have 15. So this is 1, right? We've iterated once, right? So now left is equal to 1. We're going to check the left of 15. That's 0. Because we checked the left, we're going to check the right. This is 0, right? So our left area, this here, is equal to 1, 420. But you see we're not done yet. So you have left equals to 1. Let's go check our right area. Our right area is 7, right? Remember, we're starting at 20. We're starting. So we need to check the left and we need to check the right of 20. So the left of 20 is just 1. There's nothing else because this all just returns 0. There's no nodes after. So now you check the right of 7 because now we're in this little section. And the right is 1. And the same thing, right? You want to check if there is any values after. This is 0. So return 0. You check your left. This is 0. So return 0. And you have 1 and 1. So now what this looks like here with numbers is return the max of left or right. So left is equal to 1 and right is equal to 1. So no matter what, it's still going to be the same thing, right? But you're going to basically have return max of left and right. This will be 1. 1 plus 1 is 2. And right equals 2, right? 2, oh snap, I didn't know that would do that. Okay. To show you what would happen if, let's say if we had another node down here, right, following that example, we have our left and our right starting at 20. This is still 1. Our left here would still be 1, right? You're going to check its left, and then you're going to check its right, 0 and 0, right? So this is 1. Starting from 20, you're going to look at 7. 7 is now 1. Then you're going to check 7's right. 5 will be 1, right? And then you're going to check 5's right. There's nothing. Then you're going to check 5's left. There's nothing. Then you're going to go back up. You're going to check 7's left. There's nothing. So you have 1 and 1. So now you have 2 and 1. And going back to the code, let's say now right is equal to 2. Return max of left and right. Obviously right is the higher value, so you would return 2. 2 plus 1 is 3. And obviously that wouldn't work because remember how we said if your value, if the difference is greater than 1, then return false. So now saying that out loud, you have an idea that we haven't even implemented that part yet. And that's the last step, right? So we need to make the edge case, right? If left minus right is greater than 1. How are we going to write this? So we're going to do if left minus right is greater than 1, right? And looking at this, remember how when we first ran this line here, and this was equal to just 1 because this was 0 and this was 0. 0 plus 1 equals 1. Let's remove this and instead have just the main values. We'll actually scroll out and we'll even have it here. So left equaled 1. And for this example originally, right, so scratching all this, right? And you have right equals 2. If we did left minus right, this would be negative, right? And to be honest with you, we don't want any negative numbers, so we're just going to do this quick function called ABS. This is absolute value, right? Basically meaning if you subtract numbers and it gets a negative, just make it positive, right? And if it's greater than 1, right, then we are going to want to set balanced at index 0 equal to false, right? This is basically how we get away with editing values outside of the function we're in. And then we were just going to return 0. Perfect. So now we have our edge case, which checks that condition we mentioned about. And with that, I think all we need to do is just call the function. So we're going to call helper. And inside for node, we are going to put in our root, right? Because that's what we mentioned. And then we want to just return balance at index 0. And let's give this a run. Beautiful. Let's give it a submit to see if we check all the cases, and we do. Awesome. Okay. So, with that being said, we just have our variable here. Remember, we set the list, we make it into a list so we can edit it. We can edit it within the function, right? Because it's outside. We set up edge cases. This is an edge case and this is an edge case. This one is pretty universal because this is basically checking if there are, if we ever hit a node that is nothing, just return 0. We return 0 instead of none because we are subtracting and constantly adding, so numbers can't add or be subtracted by none. That would give you an error. You set variables left and right equal to the recursion of the steps that you want checking. What this does is basically allows us to run specifically the left and right side. So left would be equal to 9 here, and right would be equal to 20. And then we return, this line here is basically what's being run over and over again, right? So for 20, once we hit, helper no.left, this automatically starts basically saying, okay, like let's run this function with no.left. And then we do this return statement specifically for no.left's value. So, no.left, right? This is 9. No.left is 9. 9 will have its own left. It will have its own right. And you need to return the max of its left and its right, which in this instance it's 0, right? Because there's nothing. And then you would just add 1. That's how you get that 1. And now you run this line right. So you have right equals helper.no.right. This is like, okay, so instead of node, we're going to do no.right. Let's run this return statement with no.right. So no.right is 20. 20 will have its own left, 15. It will have its own right, 7. Right? We want to return the max of it, which if this is 1 and this is 1, the max of 1 and 1 is 1, right? So you have 1 here. 1 plus 1 is 2. And now you have left equals 1, right equals 2, right? And we can finally run this if case, right? If left 1 minus right 2 is greater than 1, 1 minus 2, and it's the absolute value, so it's just 1. Is 1 greater than 1? No. So this is just automatically ruled out. We don't need to do any of this stuff below here. And we just return balanced at index 0, which would, because it didn't change, is just set equal to true.